Good morning and welcome to Race Industry Now, the weekly webinar series from ePortrade, presented to you by ARP, Performance Plus Global Logistics, Feria Racing Components, Peak, Quarer, and Fifth Third Bank Motorsports. I am Francisque Savignan, the founder and CEO of ePortrade, the racing industry, every minute, every day. This is episode 465, and we're going to be talking racing batteries. With me this morning are Judy Keane, the co-founder of ePortrade, and wonderful host, Mr. Brad Gilly. Judy?
Thank you, Francisque, and thank you everyone for joining today. I'm excited finally to have Kevin with Lithium Pros on this webinar. It's going to be very technical, which we love. And we have a special guest that's joining today, very last minute, Jed from Excess Power Battery. So we're delighted to have him on as well. Brad?
Awesome. Well, thank you very much, Francis. Thank you very much, Judy. We appreciate that and really looking forward to a big one here today. So we'll see you guys here in about 45 minutes or so as we talk about not only new technology, but also things that are great for racing and for racers. Very excited about this. The title of today's webinar, Advanced Batteries for High Performance Racing by Lithium Pros. And again, joining us, Kevin Bennett, the president of Lithium Pros, and Jed Emert, the performance sales manager for Excess Power Batteries. And a lot of fun. So, Kevin, Jed, welcome, and it's great to have you guys here today.
Hey, we're so happy to be here on with you, talking with you this morning as well. And certainly, first of all, my title is President of Lithium Pros Batteries, and now CTO of Systematic Power Solutions, which is the parent company of Excess Power Batteries. So, guess what, Jed? I'm working with you.
It's a pleasure to be working with you, Kevin. Yeah, I'm Jed Emert. I'm the performance sales manager here at Excess Power Batteries. And as Kevin said, we're going to be working together. And that's why we're here together today, just to try to hopefully, give your viewers some insight on some battery options and all the happenings of batteries going on in the world.
Yeah. I just wanted to say right up front that we're going to jump into advanced lead acid batteries versus advanced batteries. But this is going to focus on some of the technical challenges, some of the opportunities, different types of chemistries. We're not covering EV racing. That's a whole nother animal. That's high voltage. This is all low voltage stuff. This is really things that are for internal combustion engines. So if it shakes the ground, we're going to talk about it today. So.
Yeah, we like shaking the ground here quite a bit, which is going to be a lot of fun. I do want to let you know, we're going to have a little bit of a PowerPoint as we describe some of the things and talk about some of the things that we're covering here today on the webinar. But as always, at any time, please, if you have a question, type it into the chat. We would love to be able to answer what you want to know about. Again, this is your webinar. This is like we're at a trade show. And if you're talking to Kevin or Jed, you might have questions directly for them. So don't let that stop you from asking all of the questions right here if we're doing this here live. And we'd love to do that. So, Kevin, let me turn it over to you to sort of get things started with the PowerPoint. And we'll just kind of, jump in along the way and certainly insert wherever we need to.
That sounds great. And so the PowerPoint I've prepared kind of gives us an overview and then touches on some of the technical aspects, but please jump in, interrupt me when you got a question, and we'll go from there. So I'm going to go ahead and share my screen and get this going for us and do a screen share and just go ahead and get this PowerPoint going.
Awesome. We can see that.
Good. Wonderful. I just want to put myself in presenter mode here. And so first of all, of course, as we said, this is about comparing the different types of batteries. Now, here's an interesting little thing. I had to remind Jed of this. Excess Power goes way back in lithium batteries. Excess Power Batteries won the best new racing product at SEMA 2009. This is 2024. That's a long time ago. We've been in lithium batteries in the racing industry for a long time. Now, in racing, of course, there's common chemistries. The first one, of course, is the AGM or lead acid battery. That's what everybody's kind of familiar with. LTO, lithium tantalate oxide, is an advanced battery. LFP, or lithium iron phosphate. And now the new sodium ion battery. That's the chemistry is like, what are you talking about? I can tell you the first time I heard of a sodium ion battery is about 10 years ago at Oak Ridge National Laboratories here in right outside of Knoxville. But it's just in the past couple of years, it's come into commercialization, and especially the past year, we're really excited about it, and I'll show you why. Now, first of all, the AGM or lead acid battery. This is an interesting graph on the screen. This is what they call a radar plot. And the goal here is to get to the outside circle. You know, the closer you get to the outside circle, the better off you are. The closer you are to the center, the not so desirable. You'll notice the orange shape that's kind of in the middle of this radar plot is lead acid batteries compared to lithium ion. So lead acid batteries are closer to the center. They're well known, they're available, they're understood, but they have their limitations. You know, it's great that lead acid batteries are almost 100% recycled here in the United States. You know, the United States has an amazing recycling effort, but lead acid batteries have been around for, you know, over 100 years. They've got their limitations. They operate in a -4 to 122 Fahrenheit. They operate in a different voltage range. So you're looking at a voltage range of 1.75 to 2.4 volts. So that's 12-volt batteries, 14-volt batteries, 16-volt batteries are all in the realm of lead acid. Charging current, this is an interesting thing. You know, charging lead acid batteries is typically 0.05 C to 0.5 C. Now, when I say C, what in the world am I talking about? Well, when you're establishing the rates on batteries, it goes according to the amp hour capacity of the battery. So let's say, for instance, we have a 100 amp hour battery, and we're going to charge it at 0.5 C. That's 0.5 times 100. That would be 50 amps. And at 50 amps, we would expect the battery to be full, in theory, in 2 hours. In lead acid, that's not necessarily true. It's going to be longer than that. But lead acid batteries are typically about 0.3, about 3 hours of charge rate, about 33 amps for a 100 amp hour battery. So you can quickly see the lead acid battery is limited in its ability to accept energy fast. Now we move on to LTO, lithium tantalate oxide. And you look at this radar plot and wow, look how far all of those data points. The energy density is a little bit lacking on LTO, but cycle life, power density, charging speed, temperature, safety, all of those data points around the circle, the LTO battery hits that outside ring. That's just an amazing battery. So in a little fun fact on this, Excess Power has been, you know, offering these for over 10 years, LTO batteries for the racing industry. I mean, it's just an amazing technology that really is I think the leader of all the advanced batteries, really. Now, LTO can operate at -40 Fahrenheit up to 131 degrees. So you can see that wide temperature range. Remember, lead acid was -4. We're looking at -40. So that's a great cold weather product. The voltage range, 1.8 to 2.85. So now 12-volt batteries end up being 5 cells, 6-cell batteries end up being 14.4, 7 cells, 16.8, etc. And charging. Now, this is an amazing data point. You can charge LTO up to 10 C. That means 10 times its amp hour capacity. That would be charging a battery full in 6 minutes.
Wow.
You can see you can slam the energy into LTO batteries. That's why this is the battery of choice for, let's say, hybrid racing, where you're slamming energy into a battery, taking it out of a battery. You know, something that can handle that kind of in and out fast. You know, a lot of batteries can discharge quick, but the LTO can take it quick. And that's a key data point right there. So, and then of course we move on to the LFP, the lithium iron phosphate battery. Now on this data plot, you've got you've got a battery here that kind of it's a nice little round shape. I mean, it kind of hits all the boxes. It's that orange shape with the green fill in the middle. And so it's a great all-around chemistry, and that's why you can see it's so well, accepted in racing right now, and it has been for a while. And of course, Lithium Pros has been working with LFP for the past 13 years. So, The temperature range is 32 Fahrenheit to 140. Now you can charge at lower temperatures than 32, but that usually involves some type of heating system, little blankets or heating pads or whatnot. So the core temperature of the battery, the cell, has to be at 32 for safe charging. That 140, that's a rating, but I tell you, LFP batteries are just like you and I. They don't like being in the extreme temperature extremes. We don't like standing around at 140 degrees, and they really don't. They can do it, but they really don't like it. So you want to keep it where you'd be comfortable. The lithium iron phosphate battery is a 2.5 to 3.65 volt battery. So, you've got numbers with 4 cells like 12.8 volts or 5 cells, 16.0 volts. With the charging current, here's another interesting thing. They can accept charge pretty fast. So you can charge a lithium iron phosphate up to 2C. There's some out there that are about to be commercialized that are 4C. But what's available in the market right now, you can charge at 2C. You're limited, so they charge very fast. And I tell you another little caveat to this whole charging thing. And it's a very big difference between the lead acid and the lithium iron phosphate. Lead acid batteries spend 1/3 of their time in bulk charge, and then they spend 2/3 in absorption. So if we go back to our initial slide there, we charge a battery at 50 amps. It's only spent 1/3 of its time at 50 amps. It's going to spend 2/3 less than 50, kind of sloping off. The lithium iron phosphate battery is going to spend 93% at bulk. I mean, it's like speeding up to the traffic light and slamming the brakes. It's going to go right to 93%, and then it's going to go into absorption mode for that last 7%. So when you put the two characteristics together of up to 2C charging and 93% in bulk, that's why an LFP battery charges so fast. I mean, drag racers I've talked to, I don't know about you, Jed, but drag racers I've talked to, they're seeing 15-minute recharge times in the pits between rounds,
Yeah, obviously. And when you get to, especially for drag racers or round track racers, or, there's a short turnaround time between their next run, obviously if there's a long time, you're not really worried about charging time. But when you get to that, you're in the final round of a drag race, or you're between, qualifying in a heat race for a round track race, you don't want to be worried about whether your battery's going to be fully charged to pull on the racetrack. And that's where the lithium phosphate, lithium titanate stuff is going to be extremely advantageous over that AGM stuff.
Absolutely.
Kevin, if you don't mind, curious question on this.
Sure.
So when we talk about charging, I think of myself, and I always relate a lot of the stuff to my motorcycle. I have mine sitting on a battery tender right now, and it's an AGM battery. And, like you, it starts flashing green when it's got that bulk charging, and then it stays, for a long time until it goes solid green. Do I need a special charger for any of these lithium batteries? Well, what I have works. How does that happen?
It's a great question. And for the lithium iron phosphate, what we've recommended is just use an AGM compatible charger. Now, the big difference between a lithium charger and any type of lead acid charger is the float stage. So technically, lithium batteries don't like to be float charged. They can handle it. LTO can handle it. LFP can handle it, but they don't like it. Other types of lithium batteries, you absolutely do not float charge. Other chemistries that we don't commonly see in racing. So that's why you've got this and other chemistries would require dedicated specialty chargers. But if you're talking about a 12-volt LTO or 12-volt LFP type chemistry, then you can use an AGM charger. If you do not have access to or don't want to use a dedicated lithium charger. Keep in mind, your alternator is a charger. So people think, I gotta have a special charger. Well, you're hooking up to an alternator. The alternator is your biggest, rowdiest, meanest charger you got. And so the battery's got to be able to handle that. So if we put enough electronics in it to handle that, then that's why we say you can use it with our product. Now, I'm not speaking for the entire industry. I'm speaking for our products. You can use an AGM compatible charger. Does that answer your question, Brad?
At 100%. Absolutely. You're talking about all these fast charging speeds, and I'm thinking, wow, will what I have work? It's good to know that it will.
Yes, absolutely. Okay, so the graphic we got on the screen now is the sodium ion battery. Now, the sodium ion battery, that's the purple fill in the middle of this radar chart. And of course, the other shape around there is the other lithium ion chemistries. So it's comparing the sodium ion in this graph to other lithium chemistries like lithium iron phosphate, like a nickel, cobalt aluminum oxide, and cobalt manganese, and many other chemistries. So we can see the sodium ion battery is very close. It's a little low on energy density. You see that on the left side, it's kind of sliding in there. A little low on power density, although I tell you that's coming up quick. But the safety, the temperature tolerance, the charging speeds, those are out there, and they're just going to improve. I mean, we're working, both of us now are working on sodium ion batteries, and we have been for over a year. And we're working with the PhDs that develop the cathode material, that are commercializing this. And I see a lot of in racing industry, keep an eye on sodium. I think you're going to see a lot of this coming forward. Now, here's why. Of course, the sodium ion battery can charge at -4 Fahrenheit, and there's not too much racing under -4, although some people do it, and up to 140. There's a lot more 140 out there racing. Now, one little note I'll say about this, not all sodium ion batteries can charge this cold. So when I put this graphic up, this is for our product. This is not for all sodium ion batteries, because there's 3 major types of sodium ion batteries, and there's several subtypes. So we're dealing with layered metal oxide, specialty electrolyte, so that we can charge at -4. So don't, just because you see it on Amazon doesn't mean that it can do it. The voltage range, 1.5 volts to 3.85. So you're looking at 12-volt batteries or 15-volt batteries. And here's another interesting thing, is that a sodium ion battery can go all the way to 0 volts safely. And which is great. I mean, I don't know if that ever happens. Does that ever happen? Do people ever run their battery down?
Never, hardly ever.
Ever.
Yeah,
It never
right.
happens, right?
Yeah. Never happened to me.
Yeah, I think that happens when you lose the race in the semifinals. You're all mad at which guy on the pit crew screwed this up. Y'all slam the car in the trailer, and it's not till next Tuesday that you realize you left the car on. Great. Now what? The sodium ion battery is going to be more resistant to that type of really deep discharge damage. I mean, let's call it what it is. That's what it is. And so the sodium ion battery is going to be much better at that. Again, fast charging, you can charge up to 2C, so they charge very fast too. So another area to look at, energy density. And, on the extreme left side of this graph, is the AGM battery. This is the measure of the amount of energy per pound. So AGM batteries, lead acid batteries, when I say AGM, I'm talking about lead acid. AGM just is the way we suspend the electrolyte, absorb glass mat, but it's all a lead acid type reaction. That's on the extreme left side, relatively low energy density. LTO, you can see, is also relatively low energy density. So it's small amount of energy versus the weight. The LFP, high energy density. And then, of course, on the far right side of the graph, your sodium ion battery, lagging the LFP a little bit, but coming up quick. Now, cycle life, total different picture. The AGM battery barely registers on the extreme left side of the graph. The LTO is ridiculously long cycle life, 20,000 cycles. I mean, you're talking decades of cycling. The LFP battery is certainly improving, still long cycle life. I mean, you're still talking 10 years. And of course, the sodium ion battery, cycle life is a little bit less, but again, that's improving as well. Now, safety. People are concerned about safety of batteries, and rightly so. I tell people, anytime you store energy in any form, I don't care if it's electricity, I don't care if it's race fuel, I don't care if it's anything. Anytime you store and kind of contain energy, you have risk. The greater the energy, the greater the risk. Storing kerosene is going to be one level of risk. Storing nitromethane, different level of risk. So it's the same thing with batteries. It really is. You know, when you have more energy in a confined space, you just have to think about that. The AGM battery is a relatively safe product. I mean, it's a non-spillable battery. It can vent if you made it with the wrong charger. That's probably the most common mistake people do with AGM batteries. Put the wrong charger on it, or maybe it's the quote right charger, but it's just a poor quality charger. They claimed it was an AGM charger, but it's not regulated well enough. So you end up cooking your AGM battery and then you're all mad at it. Well, it was the charger. It wasn't the battery. They can produce hydrogen gas if you overcharge them. Think bad alternator. That's where you're going to get, that's your culprit for overcharging any type of lead acid. The LTO battery, it's considered the safest of all the lithium-ion chemistries. It's resistant to overheating, thermal runaway. I mean, if there's a rock star of lithium-ion batteries, this is the rock star right here. It's amazing. The LFP battery, very safe, but it does require a BMS if you're going to deep cycle it or use it in cold weather. It's very abuse tolerant. It can handle the limited float charging. It's very good at thermal and chemical stability. Now, a couple little caveats on the LFP, and I've seen in racing. There's some LFP batteries that do not have a BMS, a battery management system. That's a little computer that monitors what the battery is doing and will intervene and will disconnect the battery if it sees an out of range condition. In racing, there's a healthy debate. Should we put a BMS in or not put a BMS? And you know what? I can see limited instances for each, but if you do not have a BMS with an LFP battery, you need to be the BMS. You need to monitor this thing. You need to understand your product. Everybody in racing takes calculated risks, but you got to have good information. You got to know what you're doing. And so the LFP battery does have some lines, some limitations that have to be adhered to. Don't go below 2 volts per cell. Don't go over 4 volts per cell. Don't charge it under 32 degrees, cell temperature. And, provided a person goes into it understanding that, or they put a BMS in it and, let the BMS do all that, then they're great. The sodium ion battery, last but not least, abuse tolerant. It's got this wide temperature range, wide voltage range, good thermal and chemical stability with minimal risk of thermal runaway. It's environmentally safe. And like I said, it can be discharged to zero, so that's a big deal because people they leave parts on the shelf, they discharge the battery. So cost, the AGM battery is what everybody's familiar with. The range varies widely, but you can guess about 30 cents a watt hour, in a AGM or lead acid battery. That's about 60 cents per cycle of the battery. Now, when you go to the LTO, it's $3.10 a watt hour. Like, wow, that's a super big jump. But look at that. It's only 5 cents per cycle. The LTO battery wants to work. If you've got an application where you're going to be slamming energy in and out of that battery, the LTO is the place to be. The LFP at 56 cents per watt hour, that's only 23 cents per cycle. It's actually economical. And the sodium ion battery at 68 cents per watt hour, 24 cents a cycle, and those numbers are just going to get better from there. They're not going up, they're definitely going down. So, with all of that, that's certainly tells us a lot about, batteries and certainly we see a lot of applications. The one thing I think about with batteries and racing is there's not a one size fits all. People are like, oh, the lead acid battery's dead. No, it's not. There's certain applications for certain products, and you just have to be an informed consumer to know, what does this product do? What are my real needs? And go match the right product to the need. So, it's good to have a deep dive into the differences in all the products. So,
If I may ask as well,
of course.
one of the things, especially when it comes to new products or doing something that effectively does the same thing, but it's going to be different or be an advantage to me, as we all know, one of the biggest questions for racers is weight. Where are the advantages, disadvantages between the different types we just talked about?
Yes, your biggest weight advantage is, and the first thing you have to ask yourself is, what's the battery going to do? Is it going to store energy, or is it for pulse power? So when I say pulse power, am I using this battery to crank an engine, pulse power, or am I using this battery to power a piece of electronics? Think data acquisition, Motec or Racepack or whatever we got. Is it a long-term discharge, or is it a pulse? That's a key first question, because LTO and sodium ion, great pulse power batteries. LFP, great energy batteries. So you have to ask yourself which one is. That chart on energy density that put LFP and sodium ion out there on the high energy density, that equals lightweight. That's your lightweight. As the energy density goes up, the weight goes down. So.
Okay, that's good. And I want to ask a question from the chat here, because we probably
Sure.
should have even started with this too. Look, we know here on ePart Trade, when we're talking to racers, a lot of what's on our mind is the race car itself, or the race vehicle. Let me say, your vehicle may not be a car, could be a truck, could be a motorcycle, dragster, whatever. That's a lot of what we're talking about.
Right.
We also know you have to get that vehicle to the racetrack. And people do that various ways. Maybe you got a dually and a trailer. Maybe you got a toter home. Maybe you got a motor home with a trailer, whatever it is.
Mhm.
And, Kevin and Jed, we're talking to everybody about everything when it comes to this, right?
Right.
Sure.
Absolutely. Absolutely.
Yeah, so I was going to say, as far as like dually stuff like that, that's where like at Excess Power, we've got our LTO line, the lithium titanate line. That's what's going to be good for like under the hood. The heat obviously is a big issue with the LTO line. As Kevin was saying, that the LFP is great, super powerful, but as he was saying, like, we don't like heat. It doesn't really like heat either. So that's a situation where you wouldn't want to put the LFP necessarily under the hood. It will technically work. It'll work fine, do a great job. But again, you get in a situation where any kind of, high heat scenario, you wouldn't want to necessarily have it under the hood. So the LTO is going to be better in that department to go under the hood in a BCI case, BCI international group size case. Obviously, the lead batteries are great as well. But again, typically, if you're looking for just your everyday, driver, lead acid or lithium, either one will be great. It just depends on exactly what you've got going on. But as you said, we've got guys. Both of us have parts and batteries available for not just your race car, but we've got it for your side by side, your trailer, your motorhome, whatever you've got. We can cover it for sure.
Yeah.
And with the Lithium Pros line too, we've got a line of batteries that are made for RV use. So now you think solar storage, you think boondocking, where you've got a bank of batteries that are perhaps either replacing or supplementing a generator. It used to be you just went to the track, fired up a generator, you heard generators all day long. Well, advanced batteries are getting to the point you don't have to have generator. You can run that generator a lot less, or you may get crazy enough and get to the point where you don't need the generator at all. And that's a game changer. That's a quiet track.
Wow, that's incredible. Yeah, the specific question we had. So an LTO would be be better for a camper house battery. I'm assuming this isn't one that's going to run a generator, but this is one that's going to power my camper. So would LTO be better for that?
The LFP would be better for that. The reason the LFP would be better for that with a full BMS is because of energy density. The LTO can do it, but the LTO can do everything. But the energy density in the LTO is low, the power density is high. See, the difference between energy and power, energy is a measure of the amount of electrons in the box. Power is how fast you can get it out of the box. You can put a Chevy Aveo on a drag strip, and you can put a top fuel drag strip, put 9 gallons of fuel in both of them. They both have 9 gallons of fuel, but I guarantee you the top fuel dragster is going to go through the 9 gallons a whole lot faster than the Chevy Aveo. And it's the same thing with batteries. You have energy, the amount of fuel, and you have power. How fast can you get it out? The LTO is made for power. If you want it now, or you want to take it now. So that's why in your given scenario, I would go with an LFP battery.
Okay, so feasibly, it almost sounds like when you, especially when you start talking about solar, because those things do charge so fast that the solar is going to basically help the battery keep up with what I'm doing inside of my camper. Is that fair?
Yeah, all the advanced batteries are going to charge fast. You know, you're the only one that's kind of that I wouldn't personally recommend for a solar application is any type of lead acid. You know, it's only 75% efficient at converting input energy into stored energy, whereas your advanced batteries, your LTO, your LFP, and even your sodium now are closer, are more in the 90% range, 93%. So that means of the solar energy coming in, you're able to store, 90 to 93% of it. Whereas if you had lead acid, you'd only be storing 75% of it. So I would, in that score, I would definitely stick with LFP or even sodium
Okay.
for
Yeah,
RV.
this is fascinating because look, a lot of what we see, and I would say, especially when you start reading around internet forums and different things like that, battery threads are starting to become like oil and tire threads, never ending. Everybody's right and everybody's wrong at the same time. But let's
That's
talk
funny.
about that though. Look, there's internet hype. And people saying, well, this is on the horizon or this is not. Can we maybe dispel some of, say, the internet hype versus what actually makes it past the factory floor?
Yeah, it's interesting you bring that up. There's being in the industry as long as I've been. I mean, I've been in batteries since 2005, been in lithium batteries since 2008 myself. And over those years, there's so many things like, oh, this is the next best thing, and it comes up on your Google feed. And it's cool in the laboratory, and it never gets commercialized. It never gets commercialized because of cycle life or manufacturability or a plethora of reasons. But, when it comes down to things that are real, that you can buy today, that are useful, it's going to be the chemistries that we've got. I mean, there's some other interesting curiosities coming. Magnesium ion batteries, solid state batteries are coming along. They're great. But they're not heavily commercialized yet. Gotta wait for heavy commercialization, because that's when shake out all the problems, that could potentially come. So we keep our eyes open. I mean, I think about that, not just with batteries, but also with racing in general. You've got to go to the track every week with an open mind, or if you're closed-minded, if you stick with the same old thing, you're liable to get beat one weekend, and it's the same with batteries. You got to have an open mind. You got to look at technologies. Can't be too quick to jump in, but you can't be too slow to jump too.
Hmm. What do you say to someone who, because again, you preface this by saying, look, we are not talking about EVs. These are not
Yes.
the batteries that power EVs. These are the batteries that power our internal combustion vehicles
Mhm.
and the electronics within, and so on and so
Right.
forth. But when it comes to EVs, one of the things that does come up, and it's really cool that on your chart, one of the things was safety, but people have concerns, especially when you hear about lithium. I mean, we can't go to the airport and check a bag without them asking
Right.
us, do you have lithium batteries in it? So to answer that safety question, all of them seem to rank really high on that. What do you say to someone who does have concerns on that side?
I say that huge advances have been made in the chemistry. There's a lot of advances that have been made in the computers. I mean, like I said, I started way back in 2008. There were no computers, and it was in its infancy. And people were like, "Lithium? Who's ever heard of a lithium battery?" Like, yes, this is a new lithium-ion battery. But we've come a long ways. The industry has come a long ways. The world's come a long ways, and so there's been huge academic research and commercialized research into making batteries safe. And there's the world is going into from the gigawatt hours of energy storage into the terawatt hours of energy storage. And along that journey, safety is always a concern, not just for specialized racing companies like us, but for the world at large. A lot's gone in at the grassroots level to make this a very safe product.
Hmm. And let me ask the generic who fits what application, but also add to that again, We talk to drag racers, we talk to off-road racers, we talk to offshore racers, dirt racers, asphalt racers, 2 wheels, 4 wheels, whatever it might be. Can you give a general overview of who might fit what application?
Well, I'll be honest with you, Brad. It's a hard question. It's a good question, but it's a hard question. Ultimately, it just really depends on what the customer is doing and got going on in the sense of, you might have a guy that's in a dirt late model that's going to be weighing, the driver weighs, 250 pounds. He probably doesn't need the heavy battery. If he's trying to make weight or trying to get his percentages correct, he wants to go with something lighter. But the same token, the driver B may be 150 pounds and he needs all the lead he can get. So in that situation, it's trying to figure out what's best for each racer. And, we talk to a lot of people at XS Power, and I know Kevin does as well with Lithium Pros. We talk to a tremendous amount of people, and it's very case by case. We try to give a very generalized answer. There's no necessarily wrong answer. It's just trying to figure out exactly what you need. As a racer myself, I try to explain to people that, me and Kevin would love to prove that, adding a lithium battery adds 50 horsepower. That'd be great. It'd be great for sales. But, and the reality of it is, it's not that. It's just when you make that swap to lithium, you're gaining energy density, you're gaining pulse power, but you're also saving. The biggest thing is the weight. So if you're a racer who you believe you're getting beat by a lithium battery, it's not necessarily the battery itself. It's that the person has bought a lithium battery beside you. They're able to hang their weight or put their weight where they need to put it. So it's very case by case. Again, we've got customers, both of us that are winning with the traditional lead stuff and they're going to keep sticking with that because they need that weight. And then you're going to have the same, customer in the same type of car that's, that needs to save 40 pounds because they're like me and they really like to eat cheeseburgers. So they're gonna go with that lighter battery. So again, it's very case by case, and that's why we're happy to help when we can. If customers calling into both places, if there's ever an instance, obviously we go to a place like PRI or SEMA, stuff like that. There's thousands of people. We unfortunately can't get to every single one, but we try to help the best we can. And again, as racers and users of our product ourselves, we can kind of steer people in a better direction.
Mhm.
Are there ways to potentially solve that power problem? I'm talking about the horsepower problem in that, maybe if you have a better battery, one that's more efficient, one that understanding how long my race is going to be,
Sure.
could I put things on my, engine, an alternator application or something that now might have less of a draw from that power because my battery's compensating for it?
Absolutely. Yeah. I mean, anytime, I'm a round track racer. So a lot of round track racers are in total loss systems. They're afraid to run an alternator because it may kill a half a horsepower. In reality, if your battery was performing at 100% the entire time, that half a horsepower loss, you're not going to feel that. You're not going to be affected by that. One thing I try to tell people all the time is again, that if typically you're always going to be running a 100-lap race, that's where you're going to want to look at, okay, I want the most power dense thing that I have. I want something that's going to last the longest. That's where you're going to go with your traditional. Again, I'm a round track racer, so typically lead acid or LTO is the way to go for me, for what I do. And again, with me running an alternator. Now, if I take that alternator off, that's where you're going to that LFP with more power. That's where you're going to want to lean toward that. As far as power wise and stuff like that with the battery and the performance of the battery making power. What we found with, working with companies like HPL and other companies, we found that, if somebody has an electronic fuel injection or data grid, data system, whatever it is, the LTO and the lithium phosphate, it's not that they necessarily make more power, but everything runs more efficiently. Because typically with an AGM, the best way to describe it is, a customer that may have an impact or a drill at home, if you hold the drill wide open, it's going to pretty much perform the exact same all the way across until it's completely dead. And that's similar. That's how essentially the lithium products are going to work. You're going to be pretty much constant all the time until they're completely dead. Where with the lead battery, you're going to notice it getting weaker and weaker and weaker.
Mm-hmm.
So that's a great way, for racers to understand, all right, if I'm struggling to make it 100 laps on this lead battery, if I notice it's getting weak toward the end, that's where you're going to want to steer toward the lithium stuff. Because if you're making it to the end, you're gonna be better off with the lithium product.
Yep.
Yeah, that's a great thing to bring up too, though. Just the cycle drain or whatever
Sure,
would be
absolutely.
proper phrasing for it. I want to circle back to battery management systems.
Yes.
You had brought this up earlier. Are they required, and what is the downside risk?
They're required in certain chemistries. I especially think about lithium. I think about lithium iron phosphate, LFP batteries. I think they're required. Since I've been in the industry, I've always been a big proponent of them. Now, the battery management system, which I've got a sample here. I mean, we're talking about things like this. This is a computer board, and now all the energy that's going in and out of the battery has to go through something of this nature. That piece of electronics, if it's not designed well, that could be a source of failure. I mean, in racing, it's all about eliminating failure. It's all about doing things very repeatably. So sometimes you can look at that BMS and go, I don't know, are you helping me or are you hurting me? But if you're going to deep cycle the battery, if you're going to take all the energy out of an LFP, there's no good way to do that without having a battery management system. So they have to be in there. They have to be rated for the use. It's because that's in the path. Let's say that you've got a real large Mizir starter or something, and you're going to hit the button and crank the motor. All that energy that's going through your 2-aught cables in the car, that has to go through that computer too. So the size and capability of that computer ends up being a limiting factor on batteries. And there's a wide range. I mean, some of these computers that I just showed you, some of them from competitive products are the size of a business card. I mean, if you take your cable and look at it's comical. So you have to have a battery, and that's why there's a wide price range too, because the cost of those electronics vary widely. So when you get a true racing battery, I'm a proponent of BMSs myself, with some limited exceptions. But if you ever go without BMS, then you just need to be a very vigilant and person that pays attention to what's going on. That's I guess that's the way to say it.
You said it best earlier, the most simple terms. If you don't have one, then you are the BMS.
Exactly. That's the best way to say it.
Yeah.
Yeah.
I want to ask this question from the chat. I'm not sure how much directly it applies, but if it's something you could answer, I'm sure it could help someone. It says, hello, I'm talking, and I think English is obviously not his first language, but I'm talking about Brazil, and with great satisfaction, participating the second time in the webinar. I live in the south of Brazil, an electrical engineering student, almost in training. I've been focusing on electric mobility since 2021. My question would be the use of supercapacitors as energy accumulators for use in performance. Could you comment on something about that?
We've never heard of supercapacitors. I'm laughing at him.
So excess power batteries, we do have supercapacitors. We call them our super banks. We provide them in our BCI, again, the standard international group size cases. So capacitors are awesome for cranking power. They are incredible for starting a car, super fast, super quick. Typically, and we haven't really touched on this a lot, but like with excess power batteries, we have a 12 volt, 14 volt, and 16 volt option, and Kevin has a 12 volt and 16 volt option as well. The biggest advantage from going to 12 volt to 16 volt is that extra cranking power. You can hear the difference in the motor spinning over faster. That extra voltage allows you to start everything a little bit easier, build fuel pressure, oil pressure faster. So supercapacitors are a great way to do that, but you can also stay in 12 volt. Now the problem with supercapacitors are they are super powerful, but just as much power as they have, they dissipate that energy incredibly fast. So typically you want to run it alongside an AGM or even a lithium, depending on exactly what the situation is. But typically we recommend, run it alongside an AGM battery or a lead acid battery, again, just so you have that reserve capacity. So, if you're in a situation where a vehicle's got an alternator on it, if that vehicle starts right up, that super bank's going to charge within 30 to 45 seconds. It'll charge up super fast. Again, just as fast as it dissipates that energy, it charges up that quick as well. But if you're a total loss system, where you don't have any kind of charging system on the vehicle, that's where you're going to want to run it alongside an AGM or again some kind of a battery with some energy.
Yeah. Just back to our chart there. The energy density on supercapacitor is extremely